Good morning, students and families. I am coming to you today on this Saturday morning from my home office to do some math with you. The reason is our math test is coming up quickly, and I feel like we could use a little review, and we don't have a lot of time for that. Next Tuesday, we don't have any school, and Wednesday is a 3-hour early release. So I wanted to take advantage of it being a little rainy this morning to review some math for you, and you can watch this and practice at home. We're going to start out with subtraction with regrouping, and the reason for this is you're showing tremendous growth with multiplication and division, but where you're making your errors is when you're subtracting in that long division. So what I'm going to do is switch the camera over and do some subtraction with you, and then I will review all of the strategies that we've learned for subtraction. Nope, sorry. For multiplication and division so that you can watch them and practice and be ready for our upcoming test. I hope that this is helpful. Okay, so here's our equation, 116 minus 29. Something that I see a lot of you trying to do is reverse these so that you're doing 9 minus 6, which would be 3, but you can't do that. When you do that, you're changing the entire equation, you're creating new numbers. So if I have 6 ones here, 1, 2, 3, 4, 5, 6, can you take 9 away? You can't. There's not enough. So I'm going to build this number with our base 10 blocks. Let me go up with the camera. Okay, here's 116. And when we subtract, we're going to start in the ones place. I need to take 9 away. But I don't have 9 to take away. So I'm going to come next door to this 10 and I'm going to borrow from it. Now, unfortunately, this isn't going to make much of a difference to our equation here. I just want you to see what's happening. I'm going to come next door to the 10 and I'm going to borrow it. I'm going to take it out. Now, how many 10s do I have? I don't have any 10s, but that 10 didn't just go away. It's going to come back as 10 ones. So now, how many ones do we have? We had 6, and we have 10 more. So now we have 16 ones. Okay, now I can take away 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many ones are left? 1, 2, 3, 4, 5, 6, 7. I know what you guys are saying over there. 6, 7. Okay, even on Saturday mornings, I can't get you out of my head. Okay, 7 ones. Now I'm ready to come over here and I need to take 2 10s away. I don't have any 10s. Where am I going to get my 10s from? I need to borrow from my 100. So again, I'm going to take away my 100, and here's what it looks like mathematically. Now I have 0 hundreds, and I'm going to bring back in 10 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's the same as 100. And now I can take away 2. How many hundreds, I'm sorry, how many 10s do we have left? 1, 2, 3, 4, 5, 6, 7, 8. 8. The answer is 87. So I'm going to assume you guys don't have base 10 blocks at home, and I can't give them to you when you take a test. So let's see how we can do a problem like this without base 10 blocks. Okay, here's my new problem. Maybe I was doing some division, and this is what I need to subtract. I'm going to start in the ones place. So we always need to remember our place value. This is our hundreds, tens, and our ones, and we have to start in our ones. Okay, 1 minus 5. I Well, first things first, I'm going to actually draw my base 10 blocks. So I have 200s, which can be big squares, 3 10s, and 1 1. So don't forget, this is how you can draw base 10 blocks. Okay, I have to take 5 1s away, but I only have 1 1. So I'm going to erase one of my 10s and draw 10 more 1s. Now I need to represent this, what I just did in my problem. So how many 10s do I have now? 2. So I'm going to cross out my 3 and make it a 2. And how many 1s do I have now? 11. Now I can take 5 away. And I can use my eraser or I can cross them out. 1, 2, 3, 4, 5. And that leaves me with 1, 2, 3, 4, 5, 6. 11 minus 5 is 6. Now I'm ready to move over to the 10s. I only have 2 10s, but I need to take 4 away. So I'm going to have to borrow from one of these hundreds. So again, I'm going to erase this 100. Now I only have 100. And I'm going to bring that back as 10s. So now instead of 2 10s, I have 12 10s. Now I can take 4 of them away. And that leaves me with 1, 2, 3, 4, 5, 6, 7, 8. And I can't forget, I need to finish off in my hundreds. I have 100 remaining. So I hope that this helps because you're doing so good with your division. We just need to remember that we cannot change the order of our numbers. We have to work with the numbers in the order that they come, which means sometimes we need to go next door and borrow. And I have seen some of you try to erase the numbers that you borrow and just turn them into new numbers. My advice would be to use the crossout method so you can keep track of the work you did. So if you make a mistake along the way, you can check it. And also remember, this is a calculator unit. So while I've been discouraging calculator use throughout the unit because I want you to understand what you're doing, you do have permission to use the calculator on the entire test. Now that subtraction is out of the way, we're going to review the multiplication strategies that we learned during this unit. Remember, all of these strategies work, but they're not all the most effective ways. So we're going to go from least effective to most effective. We've learned repeated addition and equal groups, which is pretty much the same thing. The distributive property, the box method, also called the open array, partial products, and finally the standard algorithm. First, we're going to look at repeated addition and equal groups. This one is not super effective when you start to get into bigger problems. So as the problem grows larger, the more convoluted this process is going to become. But basically, like it says, you're going to just add one of the factors a certain number of times or create the equal groups. So if I had 9 times 16, this could be the same as saying 9 groups of 16. And of course, we know that this is the same thing as 16 times 9, so we could go either way. For repeated addition, I'm actually going to start with equal groups. I'm going to draw, I think I'm going to do 16 circles and put 9 in it. So like I said, this is not the most effective strategy with our 5th grade math problems, but it is a strategy we learned, so we're going to talk about it. I'm going to draw kind of big circles. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to put 16 in them, and I'm going to draw tallies. 5, 16. Okay, I'm gonna finish this up and I'll come back. Okay, that took a long time, but I know some of you still want to do this. So now that we have 9 groups of 16, we can count them up. In this case, I'm going to count my 5s and then add in the 1s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. I'm going to kind of circle that. That's my 100. 5, 10, 15, 20, 25, 30, 35. That's 135. And now bring in these ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we're going to add 135 plus 9 for 144. So that took a lot of time and drawing a lot of lines. This strategy works. It's not super effective. But also, if I were going to do my repeated addition with this, it's going to also take a long time because I'm going to be doing 16 plus 16 plus 16 plus 16 plus 16 plus 16 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to have to add all that up. And I know that some of you are still going to want to do it like this. 16 plus 16 is 32. Plus 16 is 48. And I worry you're going to get lost how many times you've added 16. So effective strategy, but not very efficient. Our next strategy is the distributive property. This is taking bigger numbers and breaking them down so they're easier to work with. We've learned it as an array and without an array. So with an array, let's see. We know that arrays are one strategy we can use for multiplication too, and again, they're not great. They take a long time to draw, but we can count that this is 3 times 6, but we could break this array up different to create 2 different problems. If I were to break it up here, I've now cut this array into 2 arrays, so I have created a new equation, which could be 3 times 3 plus 3 times 3, or 2 groups of 3 times 3, since this one happens to be the same. And when you solve them, you get 3 times 3 is 9, plus 9 equals 18. I like this strategy because we're making the numbers work for us, and it can work with bigger numbers as well. So for example, if I had, and I'm not always going to draw my array. If I had, for example, 7 times 23, I might not be able to count by 23s 7 times, but I can break 23 apart into its 10s and 1s, which is 20 plus 3. So now I can write that as a new equation. 7 groups, oh, that should be a 2, sorry. 7 groups of 20 plus 3, okay, pardon all the erasing. 7 groups of 20 plus 3. So now what I'm going to do is I'm going to multiply 7 times 20 and 7 times 3. Okay, so 7 times 20. Remember, we don't have to count by 27 times. We can do 7 times 2 is 14 and underline that because we're underlining what we're multiplying. And then we need to add in the 0 for 140. Then 7 times 3 equals 21. And now we need to add these products. 140 plus 21 equals 161. So you can break down those numbers into numbers that work better for you. We can go back to that 9 times 16 that we did earlier. And we know that 16 is 110 and 1/6. So we can do 9 times 10 plus 6, which is going to now be 9 times 10 plus 9 times 6. 9 times 6 is 54. And when we add these together, we get 144. So as you can see, that was a lot quicker than our equal groups. Closely related to the distributive property is the open array, which you guys love to call the box method. And we're going to start out with the same problem we've been working on, which is going to be 9 times 16. The first thing we're going to do is draw our rectangle, which is going to represent an array, but we're not filling it with all the boxes for the array. Instead, we're going to put our 9 here, so one of our factors goes on the side, and our other factor goes on the top, but again, we're breaking the 16 apart into 10 plus 6. We're going to draw our line down, and because we have a single digit times a double digit, we only need the line down the middle. I like to put a multiplication symbol here to remind me what I'm doing. Our first equation is going to be 9 times 10, which is 90. And our second equation is going to be 9 times 6, 9 times 6, which is 54. And then this is our addition symbol. So what we need to do is add these for 144. Nice and easy. You should see the two equations that we made in our distributive property, 9 times 10 and 9 times 6. Here's the distributive property where we have 9 times 10, 9 times 6. But we can also do this with bigger equations. So let's look at 36 times 42. Again, we can break these numbers up however we need to. And for parents, if you're watching this, I say again, because I've explained this to your children. So 36 can be 30 plus 6, but it could also be 10 plus 10 plus 10 plus 6. Same with 42. However, you need to break it down so that you can work it out, that's fine. I'll show both ways. I'm going to draw my open array. I'm going to do 30 plus 6 on one side, 40 plus 2 on the top. And this time I'm going to draw a line from both of my plus signs. And I'm going to put my little multiplication symbol in the corner. Okay. My first equation is going to be 30 times 40. And just like we did earlier, I'm going to do 4 times 3 and then add in my 2 zeros. Okay, next we're going to do 30 times 2. 3 times 2 is 6, and bring in that 0. Our next equation is going to be 6 times 40. 6 times 4 is 24, and bring in that 0. And finally, 6 times 2 is 12. Now I need to add all of those up. 1,200 plus 60 plus 240 plus 12. 0 plus 0 plus 0 plus 2 is 2. 6 plus 4 is 10 plus 1 is 11. 2 plus 2 is 4 plus 1 is 5. And 1,000 is 1,000. 1,512. Now, my first video I was working on cut me off, but I also wanted to show that I could change this problem by breaking down my numbers further into the tens. So here I wrote 36 as 10 plus 10 plus 10 plus 6, which is 36, and 42 as 10 plus 10 plus 10 plus 10 plus 2, which is 42. And I went across. 10 times 10 is 100, 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 10 times 2 is 20, and I crossed out that 10 to let me know I was done with it. And I did that for all of them. And then again, I added it on the side to get 1,512. So with the open array or the box method, you can make these numbers work for you. You can break them down however you need to. Just as the distributive method and the open array are similar, the partial products is also similar. So we're going to go back to our same equation of 36 times 42. And we're going to look at this as partial products. So we know 36 is the same as 30 plus 6, and 42 is the same as 40 plus 2. And for partial products, all of these numbers need to get multiplied together. So you need to have 4 different multiplication equations. You need to have 30 times 40, 30 times 2, 6 times 40, and 6 times 2. Which this does look exactly like the open array. We have 30 times 40, 30 times 2, 6 times 40, 6 times 2. But partial products is special because it starts to build in more of the standard algorithm. This gets a little confusing, so pay attention. I'm going to write this like the standard algorithm. Now, I'm going to use markers to show you the work that I'm doing. The first thing I'm going to do is 6 times 2. 6 times 2 is 12. Now I'm going to switch to green, and I'm going to do 30 times 40. Which equals, remember again, 3 times 4 is 12, and I need to bring in these 2 zeros. 1,200. Now I'm going to switch to orange. So I've done my stacks, 6 times 12 and 30 times 40. Now I'm going to do 30 times 2, which equals 60. And finally, in another color, 40 times 6, which is 40 times 6. 4 times 6 is 24. Bring in that 0, 240. Okay, now I don't have this written nicely to add it up, so I'm going to want to rewrite this off to the side or somewhere else to add it up. I'm going to go this way. 1,200 plus 240 plus 60 plus 12. And we got, again, 1,512. So this is starting to look more like our standard algorithm. And you can do it this way, or you can do it this way. You just need to know that you need to do 30 times 40, 30 times 2. 6 times 40, 6 times 2. That's what you need to know. That's where you're getting those 4 equations from. That brings us finally to the standard algorithm. This is the quickest way, but if you don't really understand what you're doing, you might make a mistake, which is why we teach all the other ways first. But let's dive in. 36 times 42. Okay, I'm going to use my markers again. First things first, I need to do 6 times 2 is 12. The 2 is going to go here, and I'm going to put a plus 1 up here. Now I'm going to move to 3 times 2 is 6, plus 1 is 7. Okay, now what I need to do is put a 0 or an X in the ones place because I'm done with it. You can put whichever you'd like. We're done with that. 6 times 4, 4 times 6 is 24. The 4 is going to go here. Plus 2 is going to go up here. 4 times 3 is 12. Plus 2 is 14. Now we're going to add that together. 2, 7, 8, 9, 10, 11, 5, and 1. So there is room for error in here. You can see that it's very similar to partial products, but there is room for error. So let's try one more with the standard algorithm, and then we'll move on to division. Let's do 47 times 25. So again, I'm going to grab my marker. 7 times 5, 5, 10, 15, 20, 25, 30, 35. The 5 goes here in the ones place. The 30 goes up here into the tens place, plus 3. 5 times 4 is 20, plus 3 is 23. Switching colors, and again, I'm going to put my X in the ones place because I'm done with that. 7 times 2 is 14. Put up my plus 1. 4 times 2 is 8, plus 1 is 9. Adding that up, let me switch difference. 5, 4, 5, 6, 7, 9, 10, 11, 1,175. While you're getting used to the standard algorithm and the distributive property, I would encourage you to use colors to help you pay attention to where you are. But that's it. Those are all of our steps for multiplication. I mean, all of our strategies that we've learned for multiplication. Okay, now we're going to switch to division. So here's a reminder of our language of division. We have our dividend, which is our big number, and this isn't always necessarily a big number, but it's the number that we're going to break into smaller groups, which is our divisor, the number of equal sets, and the quotient is our answer. We learned 7 strategies for division, and we're going to go over them quickly together. Our first strategy that some of you really like is repeated subtraction, and this is effective but not efficient. It takes a long time. So for the purpose of this demonstration, I'm going to use a pretty simple equation. 24 divided by 4. For repeated subtraction, we are just going to take the divisor out over and over again until we get to 0 or as close to 0 as we can. It looks like this. 24 minus 4 is 20. That was 1. Then this becomes our new dividend. 20 minus 4 is 16. Now 16 is our new dividend. 16 minus 4 is 12. 12 minus 4 is 8. 8 minus 4 is 4. And 4 minus 4 is 0. Since this one landed perfectly at 0, there is no remainder. We count how many times we had to subtract. 1, 2, 3, 4, 5, 6. 24 divided by 4 is 6. So again, this works, but it's not super efficient as we get into bigger numbers. So then we might want to start thinking about the share method. The share method is where we start to think about how our dividend is made up. So for example, if we have 56 divided by 4, we're going to ask ourselves, what do we know about 56? Well, we know it's made of 5 tens and 6 ones. So if I were to draw that in my base 10 blocks, 10, 20, 30, 40, 50, 51, 52, 53, 54, 55, 56, I could start trying to separate those into 4 groups. So I'm going to do this with base 10 and also with numbers. I'm going to draw 4 categories. I'm going to start to pass out these base 10 blocks to these 4 rectangles. So I can do 10, 10, 10, 10. These are gone. And I can do the same thing with my ones, but I have this 10 that I need to deal with. So just like when we were doing subtraction, I'm going to get rid of this 10 and turn it into 10 ones. So now instead of 6 ones, I have 10 and I can share them out one at a time, or I know that 16 divided by 4 is 4. So I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So again, we might use repeated subtraction and the share method to compensate when we're learning our fact families. Let's see how this can work with numbers. I know 56 is 50 and 6, and 50 is 10 plus 10 plus 10 plus 10 plus 10. So I can do the same thing. 10 here, 10 here, 10 here, 10 here. These are gone. But I still have 10 and 6 left. So 10 plus 6 is 16. And I know my 4s, so I know I can do 4, 4, 4, 4. 56 divided by 4 is 14 on the equal shares. Our next method is nearby facts, and I am moving us a little bit faster through division than I did multiplication just because we just finished this part of the unit. So nearby facts is anchoring to multiplication to solve division. We know multiplication and division are related, so on a side note, we can think of our fact families if I know that 6 times 4 equals 24, I also know that 4 times 6 equals 24. And because I know that, I also know 24 divided by 6 equals 4, and 24 divided by 4 equals 6. These are fact families. This is why knowing our multiplication is important, because here we have 4 equations that we can know by heart. 6 times 4 equals 24. 4 times 6 equals 24. 24 divided by 4 equals 6. 24 divided by 6 equals 4. 4 equations that we know by heart just because we know 6 times 4. So nearby facts can help us out on equations that might look like this. 23 divided by 3. Okay, so we're going to think about what we know, and I'm going to start with my divisor. How close can I get to 23 counting by threes? Well, I know that 3 times 7 is 21. And I also know that 21 plus 2 equals 23. So because of that, these numbers are important to me, all 3 of these. I know that 23 divided by 3 equals 7, remainder 2. And on another one, 67 divided by 7. I'm going to start with my divisor. How close can I get to 6, 7 using my sevens? Well, I know that 7 times 9 equals 63. I also know 63 plus 4 equals 6, 7. So, because of that, I know 67 divided by 7 equals 9, remainder 4. Next, we're going to move to the ladder method. This is again where we break up our numbers by tens and ones or hundreds, tens and ones. And this is another one where we have some options. We can do it with dots or we can do it with numbers. So let's look at 75 divided by 4. Okay, for this one, I'm going to draw a ladder. And I'm going to put 7 on the top. But this isn't really 7, it's 70 because it's in the tens place. And 5 on the bottom. Now, what I'm going to do is draw 7 dots. And I'm going to circle 4 of them. That's because my divisor is 4. So I'm going to circle that just to remind me I'm making groups of 4. So I can make one group of 4 and there's 3 dots left over. These 3 are going to come over here and change 5 to 35. So now I'm going to draw 35 dots. And again, I'm going to circle groups of 4. So up here, I was able to circle one group. Down here, I could circle 1, 2, 3, 4, 5, 6, 7, 8 groups. So this is my tens, my ones, and in the very bottom rung of the ladder, whatever is not circled becomes the remainder. So this gives us 18 remainder 3. But if I'm able to count by 4s efficiently, I don't need to necessarily draw the dots. I can do this with numbers. So I know it would be counting by 4s, the closest I can get to 7 is 4 times 1, which is 4. And then I know I still have 5, 6, 7, which is 3. So 3 is going to come over here to 35. And again, I'm going to count by 4s. 4, 8, 12, 16, 20, 24, 28, 32. Next would be 30, next would be 36. So I'm going to come off to the side. 35 minus 32 is 3. So again, we have 18, remainder 3. 2 options for that one. Next up, we have partial quotient, also called Big 7. Most of you came to my class with some knowledge of this one. We just refined it a little bit. This is again where we are going to go kind of like nearby facts. We're going to get close to our number and subtract. This is where we're starting to look like long division. So I'm going to draw my Big 7. And we're going to do 75 divided by 4 again. So 75 goes on the inside, that's our dividend. 4 goes on the outside, it's our divisor. Now, I'm going to be counting by 4s, but to save time, I know that 4 times 10 is 40. 4 times 10 is 40. So I'm going to take away 40 from here, which gives me 35. I can't use times 10 again, or I'll go over, so I'm going to use times 5. 4 times 5 is 20. When I subtract, I get 15. Now I can't use times 5 again, or I'll go over. So this time I'm going to use times 3. 4 times 3 is 12. When I subtract, I get 3. This is my remainder. And to get the quotient, sorry you guys can't see that, I'm going to add these up, which gives me 18, remainder 3. All right, we're almost done. Coming up is the lattice method, which a lot of you love, so we're going to talk about it. In the lattice method, we break our dividend into boxes. And these boxes are important because the top box is the quotient, the bottom box is the remainder. So the top box is where we get our answer from. The bottom box is the remainder. Something else we need to know, when we break apart our dividend, whether it's 2 digits, 3 digits, 4 digits, every digit gets a step on the lattice. This is our hundreds, our tens, our ones. If the problem goes into the thousands, there'd be a 1,000 box here, etc., etc. Hundreds, tens, 1. And this is where the divisor goes. So let's see it in action. We're going to do 210 divided by 4. The first thing I'm going to do is draw my lattice. I need 3 boxes because my dividend has 3 numbers, 3 digits. And each digit gets a step on the lattice. 210 divided by 4. 4 goes here. All right. So the first thing we're going to ask is, how many times does 4 go into 2? It doesn't. So I'm going to put a 0 here, and I'm going to bring the 2 down. It's going to become the remainder, which gives us a new number, 21. How many times does 4 go into 21? 4, 8, 12, 16, 20. That's 5 times. 21 minus 20 is 1. So that's the remainder. Now our new number is 10. 4 goes into 10 2 times, which is 8. 10 minus 8 is 2. And just so we can clearly see, to get our to get our quotient, we're looking at the top rectangle. My goodness. Sorry, it is 5 o'clock at night after a long day, and my brain is not wanting to do math, but I'm doing it for you guys. We're going to get the quotient by looking at the top triangle. So we have 0, 5, 2. And this guy is important as well. This is our remainder. It's what's left over. Remainder 2. So I colored that up here too. I love to color code things. Color coding things works for my brain. Ooh, I'm all crooked on you too. I don't need to write the 0. 52, remainder 2. So we're really at the end of our long division. Sorry, I read it right off the paper. Division journey. We're going to end with long division. I want to show you 2 different things before I end this video, which if you've watched the whole thing, come to me and tell me the word pickles. And if I look at you like you're crazy, remind me that you made it to the end of the long video and I will give you a little prize. So pickles is the magic word for hanging out with me. This video took 3 different times for me to make. I started on Saturday, I'm finishing it on Sunday, but you're worth it. So if you've made it this far, come and tell me pickles and remind me that you watched the video. Okay, long division. there's just a couple things that you need to know. So we're going to do two different problems. Let's start here. So with long division, the first thing we're going to do is say, how many times does 4 go into 2 or into the first number? And if the answer is 0, we have to do something special. So when I say how many times does 4 go into 2, this is what I mean. If I'm counting by 4s, am I ever going to land on 2? No. Am I ever going to get anywhere close to 2 without going over? No, because I've already gone over. So because 4 does not go into 2, and I'm going to put a 0, but you don't have to, I need to chunk these two numbers. Now, can I get close to 21 when I count by 4s? Yes, I can. We know 4 times 5 is 20. So I like to put a little multiplication symbol there just to remind me what I'm doing. 4 times 5 is 20. 21 minus 20 is 1. Now I need to bring down this 0. Does 4 go into 10? It gets close. 4 times 2 is 8. 4 times 2 is 8. Minus equals 2. There's nothing else we can do, so this is our remainder. And you have to write it as an R, because if you write it as a decimal, you're going to get the wrong answer. Decimals are different than remainders. I mean, decimals are still remainders, but 0.2 is different than this. Okay, but I actually want to make a quick change to this one. Okay, I flipped those numbers around for a very important reason. You guys are smart, and many of you are going to say, okay, 4 goes into 8, but 4 also goes into 84, and you're going to try to scoop this together. It's going to create a different answer. You have to go place value by place value by place value. The only time you can scoop it is if it doesn't go into the first one. So 4 goes into 8 2 times. 4 times 2 is 8, minus equals 0. Bring down the 4. 4 goes into 4 1 time. 4 times 1 is 4, minus equals 0. Bring down the 6. 4 goes into 6 1 time. 4 times 1 is 4, minus equals 2. Remainder 2. But if I had tried to scoop this together, 84 divided by 4, darn it, it worked in this one. I'm so bad with coming up on the fly with examples. It doesn't always work, guys. Although 84 divided by 4 is 21, there are times when it doesn't work. So be careful and just work from the left to the right. But at this point, it's been a long day and I'm tired. I'm going to go have dinner and I'm going to get this video together and send it to your parents. Please watch it, study, and be ready for the test. And remember that you are awesome. And I love you. And if I didn't, I would not have spent a considerable amount of my weekend making this video to help you be prepared for the test on Thursday. So I'm going to write that here too. Test on Thursday. And here's your final reminder, the 13th. If you've made it to the end of the video, like if you've made it this far, you can say ultra pickles. And I'll give you 2 prizes from the prize box. All right, go be awesome.